I am Aizija Khatun, student of Department of Chemistry, Bolpur College. I am presenting my dissertation paper titled Pericyclic Reactions. My lecture contains the following topics. We know that most of the organic reactions proceed through a polar or radical pathway, but there are some group of reactions which do not occur in this way. They are unaffected by change of polarity of solvent or by the presence of radical initiators. They are called pericyclic reactions. So as a definition we can say that pericyclic reactions are such reactions which follow a concerted mechanism. That means bond breaking and bond making happens simultaneously and proceed through a cyclic transition state. Now we must know why these reactions are called pericyclic. Pericyclic means electrons are rearranged in a cyclic order along the periphery of the cycle. That's why such reactions are called pericyclic reactions. Pericyclic reactions are found to exhibit the following characteristics. They are reversible in nature. They proceed through a cyclic transition state. This reaction follows a concerted mechanism. In this reaction, no intermediate formed. These reactions are highly stereospecific. This reaction takes place thermally as well as photochemically, and they are independent of solvent polarity or reagent. I will now explain the principles which follows the pericyclic reaction. The highest occupied molecular orbital HOMO and the lowest unoccupied molecular orbital LUMO are the key in determining reactivity of these pericyclic reactions. These HOMO and LUMO are termed as frontier molecular orbital. This FMO theory is based upon two principles. Principle 1 says that bonding interaction must be between two orbitals HOMO and LUMO, and principle 2 says that lobes with same phase overlap while lobes with different phase repel each other. This is how the frontier molecular orbitals look like. The first one for 4n pi system and the second one for 4n plus 2 pi system. In 4n pi system, in ground state, psi 2 is HOMO and psi 3 star is LUMO. But when it is excited by the photon or light, then one electron moves into the higher energy level, and then psi 3 star will be the HOMO and psi 4 star will be the LUMO. Similarly, for 4n plus 2 pi system, in ground state, psi 3 is HOMO and psi 4 star is LUMO, and after excitation by the photon or light, psi 4 star will be the HOMO and psi 5 star will be the LUMO. Pericyclic reactions are classified as electrocyclic reaction, cycloaddition reaction and sigmatropic reaction. But there have also other type of pericyclic reactions. But in this lecture, I am discussing these three types. Let us analyze each type one by one. First one is electrocyclic reaction. Electrocyclic reactions are such reactions which follows a concerted opening of a cycloalkene or closing of a conjugated polyene through the conversion of a sigma bond to a pi bond or vice versa. These examples for 4n pi system and 4n plus 2 pi system. In this type, orbital symmetry must be same during the overall reaction mechanism. In this reaction, only one reactant is involved, which is HOMO, and this HOMO rotates through 90 degree to overlap. If the rotation occurs in same direction, then it is called conrotatory, and if the rotation occurs in opposite direction, then it is called disrotatory. And this rotation depends on the number of double bonds and condition of the reaction. These reactions takes place thermally, where the ground state HOMO participates, as well as photochemically, where the excited state HOMO participates. The Woodward-Hoffmann selection rule for electrocyclic reaction is for 4n pi system, if the reaction is occur in thermal condition, then it is conrotatory, and when it is occur in photochemical condition, then it is disrotatory. Similarly, for a 4n plus 2 pi system, In thermal condition it is disrotatory, and in photochemical condition it is conrotatory. In electrocyclic reaction, an interesting feature is that when the reaction takes place in thermal condition, then the stereochemistry of the product is just opposite to that of the product when the reaction takes place photochemically. The another type of pericyclic reaction is cycloaddition reaction. In cycloaddition reaction, two unsaturated molecules combine to form a cyclic compound with pi electrons being used to form two new sigma bonds. These reactions may be of two types depending upon the number of pi electrons. One is 2 plus 2 cycloaddition, another is 4 plus 2 cycloaddition. In 2 plus 2 cycloaddition, both the unsaturated molecules have 2 pi electrons each, and in 4 plus 2 cycloaddition, one molecule has 4 pi electrons and another molecule has 2 pi electrons. Diels-Alder reaction, where a diene combines with a dienophile, are the most common example of this type. Cyclization operates in two modes, supra and intra. If the reaction takes place at same phases, then it is called suprafacial, and when the reaction occurs at opposite phases, then it is called intrafacial. And symmetry allowed reaction is that where a HOMO and a LUMO interacts with each other at same phases, leading to the bonding interaction called suprafacial interaction. And a symmetry forbidden reaction is that where a HOMO and a LUMO interacts with opposite phases, leading to the antibonding interaction. In case of 2 plus 2 cycloaddition, in photochemical condition it is symmetry allowed, whereas in thermal condition it is symmetry forbidden. But in 4 plus 2 cycloaddition, the reverse occurred. Another type of pericyclic reaction is sigmatropic rearrangement. In sigmatropic reaction, a sigma bond migrates along with the atom or group attached to a new position within a pi framework, an ene or a polyene. That means one end of a sigma bond migrates. These are the examples of these reactions. There are some types of sigmatropic rearrangement. One is Cope rearrangement. In Cope rearrangement, an carbon-carbon sigma bond is broken and a new sigma bond is formed. This is a type of 3,3 sigmatropic rearrangement. This reaction actually takes place through a chair-like transition state because it is more stable than a boat-like transition state. Another type of sigmatropic rearrangement is oxy-Cope rearrangement. It is actually a variation of Cope rearrangement. In this reaction, an enol is formed initially, and then it is going through a ketoenol tautomerism leading to a stable product. Another type of sigmatropic reaction is Claisen rearrangement. In this reaction, an carbon-oxygen sigma bond is broken, and in this example, an allyl-aryl ethers undergo thermal isomerization to give allyl phenols. And this is the FMO approach of sigmatropic reactions. And this is my references. It is my acknowledgement, and thank you for your patience.